All right, so this one, a tent is shaped like a triangular prism with a length of 4 feet. The front and rear tent flaps are shaped like triangles, each with a base of 3 feet, a height of 2 feet, and 2 side lengths of 2.5 feet as shown in the diagram. So this is a good one because again, you have a visual, they're showing you the diagram. If they just give you the measurements but don't show you the diagram, it might be helpful to just draw it out on your scrap paper. So for number 10, it's saying, what is the volume of the tent in cubic feet? So let's take a minute to do that one.
Okay.
And what are your ideas? What do you think you should do first?
Oh, find the area.
Right,
The
find the area of the triangle.
Great.
So the easy formula for volume is base times height, especially with the basic shapes. Like if it is a rectangle, it's going to be length times width times height. If it's the cylinder, it's going to be pi r squared times height. In this case, we said that, the reason why we looked at math is fun and the triangles spinning around is so that you can have more than one idea of what the base is. So you're looking for the cross section, or like we said, if we're at the deli, what would be a slice of the shape? So if the base shape is a triangle, even though this is a tent, most people are going to say the base is what you're sleeping on because of how we use the word in English. But in math, we're thinking of the base shape being the triangle and the length being the 4 feet or the depth of the tent that we're going to sleep in. So the volume is going to be find out the triangle and then multiply by height, which is really the 4 feet number.
Oh,
is that making sense?
Okay.
So you're doing, what is the base of the triangle? Or first I should say, who remembers the formula for area of a triangle?
There's 1/2 times base times height.
Yes. So you're just looking at the triangle, which when you get a question like this, there's a lot of numbers, right? You've got the 2.5, you've got the 2, the 3, the 4. So what this is trying to make sure that you know how to do is pull out the right information that you need. And that's why we're always looking at it and really paying attention to the reading so that we can say, I need the area of the base shape. This base shape is a triangle. In order to do the area of a triangle, I need 1/2 the base times the height, only focusing with the number 3 and the number 2. So you're going to ignore the other numbers for now. So you're saying 1/2 times 3 times 2 is going to give you the area of the triangle, and then times 4 for the depth of the whole triangular pyramid. So what answer did you come up with?
12.
Yes, so it's H for that one. Does anybody have questions about that?
Go Barney, Bernie.
No question.
All right, so no questions about that one?
No, ma'am.
No.
Perfect. So now we're moving on. It's the same tent, but now we're talking about the material to make the tent. And this time you are using a bottom. So when we did this kind of a question in the textbook, they specifically said, you're going to sleep on the grass. There's no bottom to the tent. In this one, you do need the bottom. So now that you're thinking of making the tent out of material, this is now a surface area question. So you need to, now you're going to include these numbers of the side length, like the 2.5. And you're thinking to yourself, how many sides are going to be on the triangular prism? You need to come up with area for that number of sides.
Okay. 5 sides.
Right, 5 sides. You've got the left and the right. You've got the 2 triangular parts of the front and the back, and then you have a rectangle for the bottom. So when you figure out the area for those 5 sides, and what I normally do is I say, what's the left times 2? What's the front times 2? And what's the bottom? You know, but you can do it as just addition. So if you say, what is the left side? You've got 2.5 times 4. So what would be the area of the left or the right side?
Is it
10.
5?
Yep, you would have 10, right? So you have 2,
Okay.
and you can do it on the calculator,
Okay. 2.5, 2.5.
or you can do it, say you don't have the calculator, you can just do it with fractions. If this is a question that falls on the test when there's no calculator available, or you can just do it in your mind, right? So like 4 halves, however you want to break apart the number, you can say, if I have 4 halves, I have 2 more, right? So I can say 2 times 4 and a half times 4 and come up with 10. Or you might be able to do the decimal if you want and just think of 50 cents, right? If I have 4 50 cents, that's $2. So however you're thinking of it, but you want to make sure that, especially when you get halves and thirds, that you're practicing the mental math, because it could be on a section where you don't have the calculator available. But what you're saying is the left or the right is 10. And then you're going to say times 2. So once you figure out one, you now know both of them. The triangle was it 3 and 4?
3 and 4.
2 and 3. So you've got 1/2 the base times the height, or 1/2 the height times the base. But because you're going to do 2 of them, you don't even have to take 1/2, right? So it's up to you how you're really thinking about this in your mental math. The triangle, you could just say 3 times 2 is 6. Because the 2 triangles are going to make the square, right? Or you can say 1/2 of 2 is 1 times 3 is 3, and I'm going to double that, and I'm still going to get 6. So far you've got the 2 sides, and however you want to do.
Then 3 times 4. This isn't it 38? Okay.
Yep, and then you have 3 times 4 as the bottom.
3 times 4. Yeah.
So you're doing the bottom, the front and back, the left and right. That's going to be your material, or you're thinking of surface area.
Mm-hmm.
So you're right. It's 38. Any questions about that one?
No, you were very good explaining it. Thank you.
Thank you, Gladys. So that was all about the regular shapes, turning them into prisms. Now this next section is about the pyramids, cones, spheres. So these are a little bit different, but like we said, these are the ones that are the more challenging problems. So if you did have a chance to spin through the practice test before, you can see a lot of times they just give you the box or the cylinder or the cone, you know. A lot of people say they don't even get the pyramid or the sphere. So it depends on what version of the test you're gonna get. But like we saw when we looked at the task practice on the task website, you do have a formula sheet. So the area equals length times width is not on there because again, they're saying that you're introduced to that in elementary school, which is why it's on study jams, right? So that's 6th grade, you know, between 4th and 6th grade, you're introduced to the idea of area. Even if it's with blocks, like the little blocks that you put together, you're kind of introduced to saying, oh, if I get 2 rows of 10, that's 20, right? So those formulas are not on your formula sheet, but we saw that the other more involved formulas are on the sheet. So for these, I think the best thing you can do is get familiar with them so that you are saying which one you're going to be looking for if you need to go to the formula sheet. But just know that you just have to know where to find the information. So you don't have to memorize all of it. What we did before is really memorize and then say, okay, base times height is regular volume. Now we're getting into some of the other kinds of shapes. So for this one, you're going to use the same information for questions number 12 and 13. So what we have is a square pyramid, which is the basic pyramid, has a base with side lengths of 12 centimeters and a height of 8 centimeters. And this one is not drawn, so you have to just get the idea of the shape yourself, right? So what we said about the square pyramid is that it's similar to the cone. So if you can remember that that is 1/3, right? The cone is 1/3 of the cylinder. You're kind of like stacking what you're remembering with dominoes, right? So you're saying, I know this one thing, that'll knock over the next thing, that'll knock over the next thing. These are like triggers for your memory. So the pyramid is similar in that it's 1/3 of the base times the height. So when they're saying what's the volume of a pyramid, of course, you're doing this on your handout. You can flip back to the textbook if you didn't remember that one. But you also want to just say it's similar to the relationship is the same as the cone and the cylinder. What you would do with a box and a pyramid is the same. So having a square base, the capital B is just what the base would have been. So in this one, the base is 12 times 12. Right? They're telling you it's a square base by saying the side lengths are 12. So you're just going to do 1/3 12 times 12 is the base, and then times height. So you should be picking out which one?
B.
J.
It's actually
Which one we at? Wait, there's no J. We at? We in 13? No.
12.
Oh, my bad. I'm sorry. I'm looking at 13. Okay.
No problem, but yes, you're right. B is 13. So great job with that one.
Okay.
So this one, did anybody have any questions for 13? Gladdy did give the answer for that one.
I basically use the same steps.
Yeah, it's kind of like the tent, right? You're going to have to find the area of every side of the pyramid and then put it all together. So this is why we're saying, like, even now, I don't know if you all decided whether or not you want to do 7.4 in this practice exercise, but once you're getting to this point, it's just, you know, different scenarios, but it's the same formulas that we have already gotten. So if it says it straightforward like this, what is the surface area of the pyramid? You're just thinking about, I'm doing all of the areas of the sides and adding them up. If it says volume, then you're, you know, then using the volume formula. So the most challenging thing is going to be if it's a scenario, you picking out which one to use. If it's not a scenario, you're reading and making sure you pick out the right formula. So let's see, I think we have time to do some more. Well, we might be able to finish them all. We shall see, right? Okay, so number 14. You're doing the same thing. This is the same information for number 14 and 15. An inflatable ice cream cone has a diameter of 10 inches and a height of 12 inches. Approximately how much gas in cubic inches is needed to inflate the cone? So is this volume or surface area?
Volume. Diameter of the height and 12 inches.
That is volume. Isn't it volume?
Yes, because you're talking about the inside, right? So a balloon, you know, when they're saying inflatable ice cream cone, they're talking about either like, you know, how people have pool toys that you have to blow up, or helium balloons, right? So if they're saying how much gas, I'm taking it to be a balloon. So what you're saying is how much can fit on the inside. That's going to be volume. And then yours, what we just did with the pyramid, you're saying a cone is 1/3 of the cylinder. So you should come out with this formula. The regular cylinder formula, pi r squared with the height, but it's a cone, so you only need 1/3. So now this is just the replacing. If they tell you that the diameter is 10 inches, you're gonna make the radius 5 inches. They told you the height is 12 inches. So now you're just doing the order of operations. And we said if you're using a calculator, which you probably will with any of these kind of formulas, because they're going to tell you to use pi or tell you to use 3.14, you're going to convert the 1/3 to the 0.3333, however many threes you want to use. So my suggestion is to use at least 3, but you can use 4 threes if you want. So you're saying 0.333 times 3.14 times 5 times 12. Yep, it's F.
Okay.
And now for the slant height, let me see if I can just pull this one up.
Oh, my pencils are breaking.
So this one is a more, they gave it in a more complicated way than in the textbook. Let me flip to the textbook.
Okay, let me see. 1, 2, 3 times surface area for the cone.
Is this,
Surface area. What is it?
So in the textbook in 7.3, the one we were doing before this one, here's the surface area. So what they said is to find the surface area of a cone, add the lateral area to the area of the base. So they have the formula for the lateral area, and then they have the base. So the lateral area is kind of like they're saying the base height, they put capital L, is equal to 1/2 times the circumference of the base times the slant height. So they're labeling it that you're gonna do the lateral area, and then you're gonna do the base, which is a circle. So the pi r squared is the circle. The pi r lateral area is coming from them doing this formula. So here, the capital L is the lateral area. The capital S, capital A is surface area. So what you're gonna do is say pi times the radius times the slant plus pi times the radius squared.
Okay.
gonna be the surface area only.
Okay.
269.
282.
So flipping back to the actual choices, you're picking out C.
Maybe C.
Yeah, see. That's what I got. Good.
Great job. And these are the last ones. So number 16. Approximately how many pounds of water are needed to inflate a spherical water balloon to a diameter of 10 inches? Round the answer to the nearest hundredth. Use 3.14 as an approximation for pi and 0.58 ounces per square inch as an approximation of the density of water. So this one, you need to think about, what is the spherical water balloon? What does that mean?
They're talking about the flat top circle.
They're talking about just a regular sphere.
Okay,
So
regular
this
sphere.
next one.
4 pi radius.
So now you want to, are you going to use volume or surface area if you want to inflate it
Volume.
with water, right? So you're doing volume when you're talking about pounds of water to inflate the water balloon. So you want to pick out this formula. Volume equals 4/3 times pi times radius cubed. Now the other part of this is, let's go back to the question. 0.58 ounces per square inch is the density of the water. So this is the second part that you had to say, which we had another problem like this. If you're doing 0.58 ounces, you want to figure out what that would be. You know, you're converting ounces to pounds. So you have to recognize when you're reading a problem that they're talking about pounds of water, but then they're giving part of the answer or part of your information in ounces. So you want to convert that, right? So how many pounds, how many ounces are in a pound?
16.
16, right? So this is the number that's not in the problem that you have to just know. And I think that what we're going to do is spend a week in measurement again, just to be familiar with it. Because that's another thing that they're just assuming adults know. So we said sometimes you have to convert time. Sometimes you have to convert weight, like pounds and ounces, grams, you know. Sometimes you have to convert other kinds of measurement. So we can see sometimes in these problems in geometry, they gave us how many feet are in a mile, or, you know, other types of measurement conversions, like days to weeks, seconds to minutes and hours, right? So those are the things that are your background knowledge that you already have to know. So what we're gonna do, we'll flip over to the whiteboard. You kind of have to do those two steps. So first is doing the volume.
So it's 5 times 5 times.
So for this one, we've got the diameter of the balloon is 10 inches. So I heard Gladys say, you're gonna use the number 5. So here you're converting this one into 1 and a third. You're gonna use the 3.14 for pi. And you picked out the right number for the radius.
Is the radius.
And it's telling you to round, right? So this is what I got, but sometimes I think I actually used 4 3s in this one. So your answer could be a little off of mine, but we're gonna round anyway. So I think I actually did 0.3333 times, well, let me erase that one.
314 times 1.
Let me just put it here. So mine came out to be 523.32025. But I'm just gonna round anyway. So you could have 523.32.33. We're just rounding to the nearest hundredth, depending on what you used for the 4/3.
Okay.
But the other thing that you have to think about is, so this was step 1. Step 2 was our conversion of the ounces to pounds. So if you're at 0.58 ounces, you want to just put that over the 16 ounces that are in a pound.
Then
So you have to just make sure you catch that when you're reading, that whenever you're talking about something in inches, but they're asking about it in feet, or they're telling you something in minutes, but they're asking you how many hours, you have to catch that in the reading. So what you're actually going to do is multiply those two numbers together. So you've got the 523 point, whichever one you used, 0.32.33 times 0.03625. And you're coming close to which one? You're coming close to H. Now, the only way that you might have gotten something different is if you didn't convert the ounces to pounds.
I didn't do that.
So step 1 is to get the volume, but step 2 is to use what they're talking about with the density of water.
97.35.
So now these last two.
Stuck in step.
Well, we're going to look at this test taking tip first. The cross section is what we were just talking about, like it could be slices. And it's telling you the cross section is the intersection of a 3D object and a 2D plane. So on Math is Fun, let me go back to that one real quick.
Oh, this one, let me see.
They actually had the slices, I'm pretty sure. Which is when we started talking about the deli, right? So the cross section is if you were going to cut straight through the object, what is going to have every slice be the same? So the cross section of this triangular prism is a triangle, and that's why we were saying base times height. A cross section of a piece of celery, they're saying when you cut it, whatever you slice, if you're doing uniform slices, that's the cross section. So here, the cross section of a cylinder is a circle. So this is why we're saying, what is the base shape? But they're even talking about the cross section of the pyramid is the square that's at the bottom. The cross section of the torus, which we didn't actually even do this shape, is a smaller circle. And then they have some examples of more cross sections. So what you're looking at when you look at any kind of shape is what is the cross section or the base shape. And then from there, you can figure out a lot of formulas on your own, just saying, let me add the height to that or the depth, however you're looking at it. So this test taking tip is just reminding you of that. So it's saying, but a plane, the most familiar cross sections of an object are its faces, but a plane can intersect the object at different places. To visualize the shape of the cross section, think of what that portion of the object would look like as a slice that is cut out. So that idea of the deli slicer or a knife slicing is just for you to hold that in your imagination, so that in a description like this, when you see the word cross-section, that's what you're thinking of, is what is one slice. So this one is just saying, what would the shape of the cross-section that is made by cutting off one of the corners of the prism? So here you're saying you're looking at a rectangular prism.
Mm-hmm.
What shape would be made if you cut off one of the corners?
If you cut one of the
It'd be a triangle.
Right, it'd be a triangle, right? So if you cut maybe like right here, just cut this corner off, you're gonna have a triangle.
Mm-hmm.
okay.
So now this is you holding it in your imagination, and you're also looking at the other ones. Once you cut it, it's not a square.
Mm-hmm.
It's not a rectangle. So you're really deciding between hexagon and triangle. So that's a pretty easy one that you're just using your imagination for and not necessarily doing math figuring. You're just doing the math, like we said, literacy, that you know what the shapes are. So now last one.
What is the area of a
What is the area in square centimeters of a cross section of the prism that is parallel to the base? So these are coming back to the beginning words that we used in geometry. Basically, what does it mean to be, what is a cross section that's parallel to the base? What does that mean?
The doesn't come up to my mouth.
Basically, you're trying to figure out which way are they cutting it. If they say parallel to the base.
It's the top one.
Right. So now, because you got to pick out which measurements are you going to use. If they said they're going to do cross sections parallel to the side, you're going to be looking at the side numbers as a measurement.
Mm-hmm.
If they say you're going to do a cross section parallel to the base, you're looking at which two numbers?
The 3, the 10, and the 3.
Exactly. So this question is just saying, what is the area of a cross section that's parallel to the base?
Parallel to the base.
It's 30 then.
10 times.
Should be 30.
It'd be 30, right? So now this is still, you're holding the shape in your imagination and the numbers are not large. You don't need a calculator for one like this. This one is just about, do you know the words parallel? Now, the reason why 6 is there is because if you're thinking I should take the 2 and the 3 and cut that slice as a cross section, then the area of that cross section is going to be 6.
Mm-hmm.
But you have to understand parallel to the base means you're slicing off the top or slicing off the bottom. You're going to have the 10 times 3 every single time you cut the shape and get a cross section. You're going to have the bigger rectangle.
Mm-hmm.
Now, the other things are, if people don't understand what they're asking about cross-section, right? So say you did 10 times 3 and got 30, and you said times 2. That's why there's J there is 60. That'd be volume.
Yep.
Right? So you're thinking of what are they actually asking me? But if you don't know what they're asking in words, just mixing up the numbers, you can get some of the answers in the multiple choice because they're going to guess. If a person doesn't know cross section, but we give them 3 numbers, they're just going to multiply all 3 and do volume.
Exactly.
Or if the person doesn't understand parallel to the base, they're going to do parallel to the side, right? So
I did the volume first, and then I just decided it has to be the 30 because that's the question.
exactly. So sometimes you can go do the test and you want to make up your own test. Like, you know what? I'm in the mood to do volume today. But some of these are the questions that might be, you're going to move faster. If you get a question like this, it's really just the literacy part. Like, have you ever heard of the term cross-section? And do you know what parallel means? So like, I really think like when we first learned these words in the beginning of geometry, we were saying, hey, I'm going to remember this from parallel parking. Or, like we're going to use the words that we already use, like base or height, and then apply them in the mathematical sense.
Mm-hmm.
So this was the end of the section. And now you're going to tell me, do you want to do 7.4 or are you done with geometry?
7.4 is more of what we're doing now.
Yes. So 7.4, if you remember, let me flip back to the classroom. What happened in this textbook was we got volume and surface area in 7.3. And that's what we just finished because we did lessons, we did the online activities, and now we kind of did this quiz that was in the task exercise book. But 7.4 was everything, but it just had to do with the composite figures. So it's the same things, but it's just a matter of combining shapes. So for 7.4, it went back to perimeter and area and surface area and volume. So now you can, if you want, you can do that. You can do half of it if you want. The only thing that's different is it's going back to perimeter and area. So it was shapes like this. Maybe you have 3 rectangles together, and this is more like a floor plan, or shapes like this where you have a circle or a semicircle added on to the rectangle.
Okay.
We did area and we did perimeter, which is taking it back to the beginning of what we were talking about in geometry.
That's
okay. We also did composites of the solids. So we did composite flats and composite solids. So if you want to do it, we can.
Okay.
Let's take a vote right now. Who says yes, you want to do it?
Okay, Miss Edu, well, based on the fact that you said that we won't get as many of those questions in the test, I don't think it's necessary for us to.
Okay, I appreciate that vote. That's what I think also, right? So I feel like just based on what you just did, you have a good understanding of if it's surface area, if it's area, if it's volume, if it's perimeter. So it seems like you have a good understanding of that. And that's pretty thorough in geometry, right? So the other parts of geometry that we can do that we didn't do on Aztec, we can combine with graphing. So that would mean we're just going to move to another chapter, but we'll still overlap some more geometry and trigonometry by going through the Aztec drills. So like I can put it up as a bonus if you want to do it and just see it. And then if you have any questions about it, of course you can ask me about it. But I do think if we have like another month together, we can probably get through graphing and through functions. And you'll definitely be ready to take your math test. So it seems like you did pretty well to me. You can always review anything that was on Khan Academy or on study jams as like a light review, but these are the most challenging questions, the ones you just did. So coming from the task exercise book, those are the ones that are the most challenging. And I think that you did pretty well with those. So that means that today is Wednesday and we don't have class on Friday. So the focus for tomorrow is just going to be the science. So did anybody have a chance to take a look at those? So it's kind of a lot on there. but I'm saying that you can continue with it on Friday when we don't have a live class.